Again, reminding us that this is the multiplication property of equality. If we have some sort of equality and then we multiply both sides by a number, the equality is maintained. Even if, and it doesn't matter. We'll do what we just had, 5 plus 2 equals 7. And let's say I wanted to instead multiply both sides by 3. Now, when we were doing this addition and subtraction thing, I just kind of like threw them into both sides of the equation. I just kind of added them on or subtracted them on. And this was easy enough because addition and subtraction, this was addition, this is addition, this is addition, this is just a number, and then subtraction. These are all on the same operation level in the order of operations. Multiplication and addition are on two separate tiers of it. So I'm going to start this wrong for a second to show you how this can get messed up. 7 times 3 is 21. That's not the mess up. You just kind of multiply, let's say this 2, because I kind of wrote it under the 2. Sure. I got 5 plus 2 times 3. Now we can do the order of operations to kind of clean this up. So we do the multiplication first. So 5 plus 6 is 21. No, that's not true. So what do we mess up? I just said we can multiply both sides of the equation by the same number. Here the quality wasn't maintained. Well, specifically here, we didn't multiply both sides of the equation by the same number. Here, I just multiplied a portion. In order for this property to work, it needs to be the entire... This C needs to look at everything that A is, and A is the entire side. So what that means, this 3 needs to multiply the entire side. I'm not even going to put a dot because it's going to be parentheses 5 plus 2. Like this. Equals... Here I don't need to do parentheses because there's no other operations that need to be like upheld and whatnot. This is just 7 times 3. Yes, we could do order of operations to clean this up. But then, 5 plus 2 is 7, duh, 5 plus 2 equals 7. Let's do something wild and do the distributive property just to kind of see if that's still a thing. 5 times 3 is 15. 3 plus 2 is 6 equals 21. Yes, that is still a true statement, so we know we did it right. Or at least we were on the assumption that we were supposed to do this and it was right, and then it ended up being right, so it just kind of like proves that assumption we were making. One final operation, that division, property of equality. A equals B. And then we can divide both sides by some number and the equality is maintained. Now I need to put a qualifier here. All a qualifier means is like it's telling us the quality of what, not the quality, but like how pristine these numbers. No, like a qualifier is just telling us what we can put into this, not like the equality, not it's an electronic quality. Like I said before, you can have this sort of equality and A on this side is equal to this, and then X can be anything. So it could just be a constant, it could be an expression, and they could be any numbers, and it doesn't matter. That's what we mean by qualifier, is like what qualifies, there we go, what qualifies for these properties, what qualifies as things that work for it. Like you have to qualify to be a pro. Just have to write off to the side over here, just so you and I remember that you can't divide by 0. Still can't do it. And yeah, so C can be anything. It can still be an expression. It can be any constant, except for any constant or expression that would equal 0 in the end. Here I'm going to do a little different example, at least with different numbers. This is going to be easier to see. Now, with the rest of these, let's see. With the addition and subtraction, I kind of wrote them down like that. Here, it was a little easier to just kind of like slap it onto the sides. And here, I'm definitely not going to use the division symbol, like I said. So you can just kind of put a little line right there saying that I'm dividing both sides by 2. This is something that I want to do to this equation. 8 divided by 2 is 4. 4 times 2 divided by 2. Well, I could just kind of cancel out those like this. If you've never seen this before, don't worry, I'm going to go much more in depth with it. But basically, 4 times 2 divided by 2, I could kind of quickly rewrite this. Okay, so this is like multiplying 2 fractions together. This being a fraction over 1, I guess, if you're more familiar with this way. And then top times top, bottom times bottom gets us to this. But this originally over here was 2 divided by 2, which was 1. We know that as 1. So that's all I'm doing here, is I'm saying I know that 2 divided by 2 is 1, and I know that I can turn this into this. So in the end, it's just 4. Again, you've probably done this before when you were learning all about fractions and least common multiples and all those other fraction good stuff. And then clearly 4 equals 4.